So okay girls, this is the next example number 2. This is a repeated 7-mark question in page number 7. If x is greater than equal to 1, a critical region for testing h0 is 0 equal theta equal to 2 and against h1 theta equal to 1 on the basis of the single observations from the population. Here f of x comma theta is given as theta into e power minus theta x, then 0 is not equal to x less than infinity. Obtain the probabilities of type 1 error and type 2 error, and also obtain the power function of the test. That means alpha and beta and the power function 1 minus beta. So we need to find all these values. So before that we need to define what's the function and what's w1, w bar and L0 and L1. And first defining f of given f of x comma theta is given as, you see that theta into e power minus theta x 0 less than or equal to x less than infinity, and h0 is given in the problem is 2 and h1 is given as 1. And the w, we need to define the w here now. You see the initial x is greater than or equal to 1 as a critical region is given. That means that is our w. So x belongs to x greater than or equal to 1 is our w. So that the remaining side is w bar. The w bar is x belongs to s and x is lesser than 1, because it's greater than 1 means so that complement is lesser than 1. So now they are defining what's L0. So L0 is f of x comma theta, theta equal to L0 means h0 is true. h0 means theta equal to 2 is true here. So that means in place of theta we are taken as 2 now. The f of x comma theta is theta e power minus theta x. That means 2 e power minus 2x for 0 less than or equal to x less than infinity. For L1, f of x comma theta, for L1 we know that h1 is true. h1 is theta 1. So that means they are taken 1 into e power minus x for 0 less than equal to x and less than infinity. Using these values, and we are going to find now that value of alpha and beta. First we are finding the value of alpha. The value of alpha, how it can obtain, alpha is equal to, as usual you know that the formula of alpha is probability of type 1 error rejecting h0 and h0 is true. And alpha, probability of x belongs to w, and h0 is true for this problem theta equal to 2, and the formula of alpha is integral over w, L0 is L0 into dx. So L0 into dx, the w, remember actually the w we are defined in before. The w is we are defined as greater than or equal to 1. So that means more than 1 it will be existing. So more than 1 will be existing means, so the w is varying from 1 to infinity, L0 into dx. So then we are replacing now L0 1 to infinity into L0. L0 we already got it previously. And previously L0 we got it as 2 into e power minus 2x. So we are replacing now. So here that 2 into e power minus 2x into dx, and 2 is a constant outside, and integrating e power minus 2x. E power minus 2x by minus 2. So the lower limit is 1 and upper limit infinity. We have taken 2 to get cancel and minus outside, and upper limit e power minus infinity, and the lower limit minus of e power minus 2. So e power minus infinity, you can take it as to be as 1 by e power infinity. So e power infinity is infinity, so 1 by infinity is 0. So the first value is 0. So the minus of minus become plus. So we got e power minus 2 alone. So e power minus 2 they taken as 1 by e square. So it's the value of alpha. Next we are finding the value of beta. So the beta is equal to probability of type 2 error rejecting h1. h1 is true, and the probability of x belongs to the w bar, and h1 true means theta equal to 1, and probability of integral, same integral over w bar L1 into dx. L1 into dx, before that the w bar. The w bar we are defined in before, do you remember? I think so. W bar we define x less than 1. So less than 1 means minus infinity to 1. Okay, so for the case we have taken less than 1, so minus infinity to 1, L1 into dx. So beta we have taken as minus infinity to 1, L1 into dx. But we already known as our function f of x comma theta. F of x comma theta is always lies between 0 to infinity, not that this lower limit is 0 only. So for that case, the minus infinity is replaced as 0 now. So 0 to 1 e power minus L1 value. The L1 we already got it previously. L1 we got it e power minus x. So e power minus x into dx. So now they are integrating e power minus x. Okay, so integration of e power minus x is e power minus x by minus 1. So again they are substituting the limit as 0 to 1. Yes, so the upper limit is minus s taken outside. So upper limit is e power minus 1 and the minus of lower limit is e power minus 0. Now, and e power minus 1 is 1 by e minus e power 0. Okay, e power minus 0 is 1 by e power 0 only. So 1 by e power 0 is 1, so 1 by 1 is 1. So we got it as minus of 1 by e minus 1. So multiply minus, so we got it 1 minus 1 by e. So we got it beta now. So now they are finding the power function of the test. So the power function of the test is, as usual, we know that the formula is 1 minus beta. So 1 minus the beta. The beta we got it just before, 1 minus 1 by e. So multiply minus inside the bracket. So 1 minus 1 get cancelled. So we got it as 1 by e will be the value of the power function of the test. So this is the solution for the second example. Thank you.